Hello and welcome to part 7 of my Quadratics series, where I tackle different ideas of quadratic functions and approaches to solving the quadratic functions. In today's video, we're going to look at completing the square. This is going to be a complete guide for you to how to complete the square for any question. Okay. Before I start showing you how to complete the square, there is one idea I would love to show you first. Okay, let's say we have a quadratic function x squared plus 12x plus 36. Okay, and I want to factorize this. So this is positive. I will take two factors that will add up to 12. I will find that these factors are 6 and 6. So I will have x, x, 6, 6. They will both take the middle sign, so they will both become positive. Or I can rewrite it as x plus 6 squared. Let's take a look at another example. Let's say we have an x squared plus 10x plus 25, and I would love to factorize this. Again, it's a plus. I will take two factors that add up to 10. I will find that they are 5 and 5. So both are the same factors. So this is going to be x, 5 and 5. They will both take the middle sign, so they will both become plus, or I can rewrite it as x plus 5 squared. Okay, the special thing about these two functions and other functions like them is that when they're factorized basically to a binomial multiplying itself. A binomial multiplying itself, or a binomial to the power of 2. Okay? Type. This type of quadratic function is called a perfect square trinomial. So, these functions are called a perfect square trinomial. The best thing about the perfect square trinomial is that they are easily factorizable. Let's take a look at some examples. I will give you some perfect square trinomials and I will show you that they can be factorized very easily. Let's say this quadratic function right here plus, so I will take two factors of 16 that add up to 8, which is 4 and 4. So this is basically going to give me x and x plus 4 plus 4, or x plus 4 to the power of 2. If I come and look, if I know for a fact that my function is a perfect square trinomial, factorizing becomes easy. It's basically square of the first number. So square of x squared is x, and then I will copy whatever the middle sign is, and then square of the second number, 4. Okay, so when I know for a fact that this is a perfect square trinomial, I can do this. Okay, and I will give you some more examples. Let's say we have an x squared minus 14, x plus 49. This is a perfect square trinomial. So without factorizing, I already know that it's going to be square of the first. So square of x squared is going to be x. I will copy the middle sign, which is a minus, and then square of the second. So square root of 49 is 7. By the way, when I meant square, I meant square root, sorry. So it's square root of x squared is x, square root of 16 is 4. Square root of x squared is x, square root of 49 is 7. And it's obviously squared. Let's take a look at another example. So x squared plus 16x plus 64. And I'm telling you that this is a perfect square trinomial, so you can almost instantly tell me that, okay, it's square of the first. I will copy the middle sign, which is this one, and square root of the first, copy the middle sign, square root of the last term. So square root of 64 is 8, and it's square. So basically having a perfect square trinomial is something I would like because it's easily factorizable. Okay, so basically the process of changing a non-perfect square trinomial to a perfect square trinomial is called completing the square. Basically, that's the whole idea. Let's take an example. So, x squared minus 6x minus 27. Okay? This function right here is not a perfect square trinomial. If I want to solve using completing the square, I will need to change it to a perfect square trinomial first. So let's say this is equal to 0. First, I will solve it using factorization. So this sign is a minus, so I will need two factors of 27 that subtract, or their difference is 6. So I know that this is a 3 and a 9. So I will do my parentheses. I will have a 3 and a 9. This is equal to 0. And the bigger factor is going to win the middle sign, which is negative in this case. So 9 is greater than 3, so it will take the minus, and 3 is going to take the plus, and I will have an x1 of minus 3 and an x2 of 9. Okay, let's try and attempt this using completing the square. I want to solve the exact same function using completing the square. So to do this, first I need to convert it to a perfect square trinomial. So how do I do that? In order to convert something to a perfect square trinomial, we have this magic formula. It's b over 2 squared. However, I only can use this when a equals 1. That's a very important thing. So b over 2 squared. My b is negative 6. So negative 6 over 2 squared. So this is going to be negative 3 squared. So this is going to equal 9. Okay, so in order to make this a perfect square trinomial, I will need it to be x squared minus 6x plus 9. Okay, so I will do that. X squared minus 6x plus 9. This part is my perfect square trinomial here. Okay, then I have a minus 27. It cannot go anywhere. Okay, and I cannot magically add a 9 to the equation. In order to balance it, when I added a 9, I need to also subtract a 9. So up until now, I have this. So if I come and look, I will find that this part is a perfect square trinomial. So as we looked at in the beginning of the video, its factorization is going to be something like this. Square root of the first, copy the middle sign, square root of the last, and squared. So this part is factorized to this binomial squared right here. And then I will do a minus 27 minus 9, that is minus 36 equals 0. Okay, now I can move the 36 to the other side, so I will have a x minus 3 equals positive 36. This is squared. So to solve, I will square root both sides. This is going to give me an x minus 3 on the left and a plus or minus 6 on the right. So my x1 is going to be positive 6, and when I move the 3 to the other side, it's going to be plus 3, which is equal to 9. And my second x is going to be a minus 6, and when I move the 3 to the other side, it's going to be plus 3, so it's going to give me a minus 3. And if I come to compare, my two x's are the same, 9 and minus 3, and I got a 9 and minus 3. So this is basically how to solve using completing the square. We will take some more examples. Let's try and take this question. X squared plus 5x minus 24. Okay, this is not a perfect square trinomial. The first step, I will need to check that a is 1. That is correct. So I can use my magic formula, which is b over 2 squared equals my b is 5 over 2 squared. So that is going to equal 25. 5 squared is 25 over 2 squared is 4. So in order to make this a perfect square trinomial, I will need to add a 25 over 4. So let's see how we can do that. X squared plus 5x. I will add my 25 over 4 to make this part a perfect square trinomial. I have a minus 24, and as we said, since I added 25 over 4, I need to subtract a 25 over 4 to not change the equation. So up until now, we have this, and we know that the factorization for this part right here, since it's a perfect square trinomial, it's very easy. It's square root of the first, so square root of x squared is x. I will copy the middle sign, in this case it's positive, and then square root of the last term, which is going to be square root of 25 over 4, which is square root of 25 over square root of 4, which is 5 over 2. So it's a 5 over 2 squared, and then I have a minus 24 minus 25 over 4. This is going to give me on the calculator a minus 121 over 4 equals 0. So to solve, I will move this to the other side. I'll have a x plus 5 over 2 squared equals 121 over 4. I will square root both sides. I will have x plus 5 over 2 on the left, and a square root of 121 over 4 is basically plus or minus 11 over 2. So for my x1 is going to be 11 over 2 minus 5 over 2, which is going to give me 6 over 2 or 3. And my x2 is going to be a minus 11 over 2 minus 5 over 2. This is going to give me minus 11 minus 5 is minus 16 over 2. So is my second x is minus 8. Yeah, okay. Let's take some more examples. Right. Let's take this example right here. X squared minus 9x plus 12 equals 0. I need to solve using completing the square. Again, a equals 1, so no problems in that. I can use my b over 2 squared. So my b is going to be minus 9, divide that by 2, square everything is going to be 81 over 4. So this is my magic number that I will add in order to convert this into a perfect square trinomial. So it's going to be x squared minus 9x plus 81 over 4 plus 12 and then minus an 81 over 4 equals 0. We know that this first part became a perfect square trinomial. By now we know how to factorize this. It's going to be square root of the first, copy the middle sign, and square root of 81 over 4 is basically 9 over 2 squared. And then I will add a positive 12 to negative 81 over 4 on the calculator. This will give me a minus 33 over 4 equals 0. To solve, I will move this minus 33 over 4 to the other side. I will have an x minus 9 over 2 squared equals positive 33 over 4. I will square root both sides. I will have an x minus 9 over 2 equals plus or minus root 33 over 2. So my first x is going to equal a positive root 33 over 2 plus a 9 over 2, which is going to be 9 plus root 33 over 2. And my second x is going to be a negative root 33 over 2 plus 9 over 2, which is going to give me a 9 minus root 33 all over 2. So this is how to solve using completing the square. Okay, let's take more examples. Let's take one final example with a equals 1. I will go through this fairly quickly. So I have an x squared plus x minus 50 equals 0. So a is 1, no problem. My b over 2 squared is going to be 1 over 2 squared, so it's going to be 1 over 4. So I will rewrite this as x squared plus x plus 1 over 4 minus 50 minus 1 over 4 equals 0. This part is a perfect square trinomial, so square root of the first, copy the middle sign, square root of the second is 1 over 2 squared, and then I will do a minus 50 minus 1 over 4. This is going to give me a minus 201 over 4. This equals 0. I will move this negative 201 over 4 to the other side. It's going to be x plus half squared equals 201 over 4. I will square root both sides. This is going to give me an x plus half equals plus or minus root 201 over 2. So my first x is going to be root 201 over 2 minus half, which is going to equal root 201 minus 1 over 2. And my second x is going to equal a negative root 201 over 2 minus a half, which is going to equal a minus root 201 minus 1 over 2. Here I can take a negative sign outside, so it's going to be a minus. This negative 1 is going to be a positive 1, and then minus root 201 over 2. And in this one as well, I can take a minus sign out, and they will both become positive, so 1 plus root 201 over 2. And this is also another way to write this. Okay. Up until now, I've been talking about the case where a is equal to 1. What about the cases where a is not equal to 1? I will take an example such as this one, which is 3x squared minus 12x minus 15 equals 0. Solving is very similar. I will just need to do some more steps. So my first step, in order to use b over 2 squared, I need my a to equal 1. So I will take a 3 out of everything. So 3x squared divided 3 is x squared, minus 12x divided 3 is minus 4x, and minus 15 divided 3 is minus 5, and this is going to equal 0. Now I will work on this inside trinomial to make it a perfect square trinomial, just like I was working on the previous examples, as now a is 1. Okay, so from here I will have a b over 2 squared, so my b is negative 4 over 2 all squared. That is going to equal negative 2 squared, so it's going to equal 4. So I will have the 3, and my magic number that I need to add to make it a perfect square trinomial is 4. So I'm going to have an x squared minus 4x plus 4 minus 5, and as usual minus 4 to keep it the same. Okay, so now this part became a perfect square trinomial. So I will have a 3, and I will factorize this part. So square root of the first, copy the sign, square root of the second, all squared. Minus 5 minus 4 is basically a minus 9 equals 0. So now I will multiply this 3 to the minus 9 to get it out of the bracket. So I will have a 3 times x minus 2 squared minus 27 equals 0. I will move this 27 to the other side, so I will have a x minus 2 squared equals 27. I will divide by 3, divide by 3. I will have an x minus 2 on the left squared equals 9. I will square root both sides. I will get an x minus 2 equals square root of 9 is plus or minus 3. So my x1 is going to equal a positive 3 plus 2, which is 5. And my x2 is going to equal a minus 3 plus 2, which is minus 1. So this is also how to solve using a not equal to 1. It's very, very similar. I will just need to change a little bit to make a equals 1, and then I can solve my question. Let's take a final question. So let's take a 12x squared minus 10x minus 5 equals 0. So this is the case where a is not equal to 1. So I will have to take this 12 out. X squared minus 10 divided 12 is basically divided 12 is basically 5 over 6x minus 5 over 12 equals 0. So it's going to be a 12, and then inside I can now use the b over 2 squared. So it's going to be a minus 5 over 6. Divide 2 is basically multiplying half and all squared. This is going to give me negative 5 over 12 squared, which is going to equal 5 squared is 25, 12 squared is 144. So this is my magic number that I will need to add. X squared minus 5 over 6x plus a 25 over 144 minus 5 over 12, and as usual I will need to subtract whatever I added to not change the value of the equation. So up until now I have this. So it's going to be a 12 times this first part now became a perfect square trinomial. So as usual its factorization is square root of the first, square root of x squared is x. I will copy the middle sign, which is minus, and then square root of the last term, which is 5 over 12, all squared. And then I will have a minus 5 over 12 minus 25 over 144. You can plug that on the calculator. It will give you minus 85 over 144 equals 0. Again, I will multiply my 12 to this negative 85 over 144. It will become an 85 over 12. So I will have an 12 times x minus 5 over 12 squared minus 12 times 85 over 144 is 85 over 12 equals 0. To solve, I will move this to the other side. So I will have a 12 times x minus 5 over 12 squared equals 85 over 12. I will divide both sides by 12. So I'll be left with an x minus 5 over 12 all squared equals 85 over 144. Since over 144, this is a divide 12. Dividing 12 is the same as multiplying 1 over 12. So 1 times 85 is 85, 12 times 12 is 144. So I will square root both sides. I will have an x minus 5 over 12 equals plus or minus square root of 85 over 12. So my x1 is going to equal a positive square root of 85 over 12 plus a 5 over 12, because I'm moving this 5 over 12 to the other side. It's going to become positive. So it's going to equal a 5 plus root 85 over 12. And my x2 is going to equal a minus root 85 over 12 plus 5 over 12. This is going to equal a 5 minus root 85 over 12. If you want to check, we can solve this using the quadratic formula, and it should give us the same exact answer as here. I hope this was clear. Please don't forget to like and subscribe, and please, if you have any questions or any topics you'd like to have a lesson on, comment down below and let me know, and I will do it. I read all the comments. Thank you very much, and goodbye till next time.